Okay, so we're going to talk about some of the addition identities, and you're going to need your reference sheet. So these are the examples that we're going to do. If you want to follow along in your book, you can do that. All right, so the first one says that they want you to condense sine theta, cosine 2 theta plus cosine theta, sine 2 theta. So essentially, all you need to do is figure out which identity it matches up with. So on your identities sheet, right, we have addition. So we know that we're adding two things together. It's a sine times a cosine times a sine. So you have to just match it up with the one that matches, right? So we got a sine times a cosine times a cosine. The angles, here's the first angle, sine of the first angle times cosine of the second angle times sine of the second angle times cosine of the first angle. So this matches up with the formula sine of u plus v. So I'm just going to write this off to the side so we know where this came from. Okay, so on our identity sheet it was sine of u plus v, but the angles here are theta and 2 theta. So that tells us this is going to be sine of theta plus 2 theta, which is sine of 3 theta. And now we've just condensed our first expression. Okay. So now look at problem number 7. All right. So again, they would like you to simplify the expression. Okay. So this time we have another addition, right? But now it's cosine of an angle times cosine of a different angle plus sine of an angle times sine of second angle. All right. So which of our identities has cosine times cosine and sine times sine, and they're adding? Okay, so that's this one, right? It's cosine of u minus v. All right, so once I figure out which one it is, now I'm going to say that I have cosine of the first angle, which is 2 pi over 9 minus pi over 18, which is my second angle. All right, so now I need to subtract, and if I get common denominators, I've got 4 pi over 18 minus pi over 18, and that is cosine of 3 pi over 18, otherwise known as pi over 6, right? So cosine of pi over 6, don't forget, you already know your unit circle, so think about your unit circle. Angle pi over 6 is in the first quadrant. So this is a small angle. This is 1/2. This is longer. This is root 3 over 2. And cosine would be my x coordinate. So the answer would be root 3 over 2. Notice in problem 1, we just left it as sine of 3 theta because it's just a generic angle. But if it's an actual angle, whether it's in radians or degrees, and it's on the unit circle, then you should substitute in an actual value. All right, so problem number 11. This time you're sort of expanding, right? So you're using sine of u minus v. All right, so now we need to expand it. So we're going to take sine of the first angle times cosine of the second angle, 3 pi over 2. And we're going to subtract sine of the second angle times cosine of the first angle. Okay, so again, if it's something on your unit circle, then you should replace it. Which ones of these are on our unit circle is cosine of 3 pi over 2 and sine of 3 pi over 2. All right, let's think about where is 3 pi over 2. It's down here. And this ordered pair would be 0, -1. So it doesn't make a triangle, but your x-coordinate is your cosine, your y-coordinate is your sine. So cosine would be 0, sine would be -1, and now we could just replace. Okay, so anything times 0 is 0. A negative times a negative is now positive, so this whole thing simplifies to cosine of theta. All right, problem 17 wants you to figure out what is cosine of 75 degrees. Figure out an exact value of it. not typing it into your calculator and getting a decimal approximation using the fact that 75 degrees is 45 plus 30. So this is one of your sum and difference identities, right? Which one does it match up with? It's cosine of adding two angles, so we're going to look at cosine of u plus v. Okay, so we're just going to expand this, and if you look at your cosine of u plus v, just follow along on your identity sheet. So you have cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. Okay, so these are all values you should know from your unit circle. We just drew out 30 degrees earlier. That was this one, right, pi over 6. 45 degrees, if you forget, that's the isosceles triangle. So this point is at root 2 over 2, comma, root 2 over 2. All right, so what's cosine of 45 degrees? That's root 2 over 2. Cosine of 30 degrees was root 3 over 2. Sine of 45 degrees is root 2 over 2. And sine of 30 degrees, back from that other problem, that was 1/2. Okay, so now you're going to multiply. You get root 6 over 4 minus root 2 over 4. And since they have the same denominator, you can combine them into one fraction, and you get root 6 minus root 2 all over 4. All right, one more example. Okay, so problem number 25, that's our last one. So 25 asks you to compute the quantity using the following data. So they want you to figure out what is sine of alpha plus beta, and they give you some information over here. All right, so figure out which sum and difference identity is. And this matches up with sine of u plus v. So we're going to expand, and we have sine of alpha times cosine of beta plus sine of beta times cosine of alpha. Okay, so some of this information we already know, right? Sine of alpha, we know that's 12 over 13. But cosine of alpha, we don't know, so that's where you have to look at the given information. Okay, so which quadrant is this referring to? Well, pi over 2 is here, pi is here, so it must be talking about quadrant 2. So draw yourself a triangle. Let's even just think about it on the unit circle. You could do something here where we've got 1 as our hypotenuse. This is 12 over 13. Right, and you remember cosine squared plus sine squared equals 1. You could do it that way. So we can say cosine squared is 144 over 169, and 1, we can replace that with 169 over 169. So cosine squared is 25 over 169. And then cosine squared is, square root. That would be 5 over 13. But it could either be positive or negative. So that's dependent on the quadrant. And in quadrant 2, it would be negative 5 over 13. If you don't like that method, the other method is to do sine of theta, sine of alpha is 12 over 13. So there's your opposite over your hypotenuse. And then it's a 5, 12, 13 triangle. And just remember that that has to be negative. So now to find cosine of alpha, here's alpha, you would do adjacent over hypotenuse. Okay, so that's another way to do it. Maybe that's the faster method. But this uses our trig identities, so I like that one better. All right, cosine of beta we know is negative 3/5. We didn't find sine of beta, but we'll go back to that. And we do know cosine of alpha is negative 5 over 13. So if we want to find sine of beta, you use the same concept. Right? Looking at angle beta, that is between pi and 3 pi over 2. So that's in quadrant 3. And since it's in quadrant 3, we know that our x and y coordinates are negative. So this would be a adjacent over hypotenuse. And that's a 3, 4, 5 triangle. But since it's in quadrant 3, I know that those two have to be negative, x's and y's. So we need to figure out what sine is. Sine of beta is opposite over hypotenuse, so that means negative 4/5. Alright, so now you're going to simplify. This will be, negative 36/65 plus 20/65, and that gives you negative 16/65. Okay, so you're using a combination of unit circle concepts. You can use SOHCAHTOA. This is our trig identity. Right? We should also remember our other trig identities. These are not on your cheat sheet here. So tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. Those are called your Pythagorean identities, but they're not listed on this sheet anywhere. So I guess you have to actually memorize those.